Hey everyone, welcome back to my channel. In this video, we'll guide our robot through a hurdles race with obstacles in a 10 by 10 grid world. Starting at the bottom left corner, our goal is to help the robot jump over 4 hurdles along its path to reach the beeper at the end. With a mix of strategy and computational thinking, we'll tackle each hurdle one at a time, teaching our robot to navigate obstacles like a pro. Alright. Let's get started with the first step of our computational thinking approach, problem analysis. Here, we'll look closely at what we're trying to achieve and the details of the setup. Here's what we know about our hurdles race problem. We have a fixed 10 by 10 robot world. Our robot starts at Avenue 1, Street 1 facing east. The goal is to reach Avenue 10, Street 1, where it must pick up a beeper. Along the way, the robot will encounter 4 evenly spaced hurdles on Street 1, each 1 block tall. The race will end once the robot reaches Avenue 10, Street 1 facing east. With these requirements clear, we're now ready to move into the decomposition phase, where we'll break down the problem into specific steps and functions. The task of navigating this hurdle race can be divided into 3 primary subtasks: horizontal movement, jumping hurdles, and picking up the beeper. First, the robot will move horizontally across Street 1, advancing eastward. When it encounters a hurdle, the robot will perform a jump sequence. It turns left, moves up and over the hurdle, turns right, moves forward, turns right again, moves down, and finally turns left to continue facing east. This pattern of moving and jumping repeats until the robot reaches Avenue 10, Street 1, where it completes the task by picking up the beeper. This breakdown clarifies each part of the task, making it easy to implement. With these requirements clear, we're now ready to move into the pattern recognition phase, where we'll identify repeating movements and turning patterns that will help us complete this hurdle race. In this hurdle race, the robot will perform the following actions. First, it will move horizontally eastward 1 time along Street 1. Then, it will jump over the hurdle using the jumping sequence, which involves turning left, moving up, turning right to jump over the hurdle, turning right again to descend, and turning left to realign eastward. After this first movement, the robot will repeat jump over the hurdle and move forward 1 step 4 times. These movements and jumps will help the robot cross each of the 4 evenly spaced hurdles along Street 1. Finally, after completing the race, the robot will reach Avenue 10, Street 1, where it will pick up the beeper once, marking the end of the race. With these patterns clear, we're now ready to move into the algorithm design phase, where we'll outline the specific moves and functions needed to complete this hurdle race. In the algorithm design step, we break down the problem of solving the hurdle race into modular subproblems, each responsible for a specific task. This modularization allows for easier implementation and reusability of the components. First, we define the turn right algorithm. Since the robot does not have a direct turn right command, we achieve a right turn by having the robot turn left 3 times in succession. This creates a simple and efficient way to handle right turns throughout the race. Next, we design the jump hurdle algorithm, which consists of a series of movements needed to navigate over the obstacles. The robot will first turn left, move forward 1 step to approach the hurdle, turn right to align with the obstacle, move forward to cross over it, turn right again to realign itself, move forward 1 more step, and finally turn left to face east. This sequence of movements ensures the robot successfully clears the hurdle and continues its progress. Finally, the complete problem algorithm ties everything together. The robot will first move 1 step forward to begin the race. Then, it will repeat the process of jumping a hurdle and moving forward 4 times, corresponding to the 4 hurdles placed on the track. After crossing the hurdles, the robot will move to the final position at Avenue 10, Street 1 facing east, and pick up the beeper. By dividing the task into these modular components, we simplify the problem and ensure that each action, from turning right to jumping hurdles, is clearly defined and can be easily reused if necessary. This structured approach to algorithm design enhances both the clarity and efficiency of the solution. Now that we've designed our algorithm, it's time to implement it and bring our hurdle jumping robot to action. The code begins with the import statement from sys1 robots import asterisk, which brings in the necessary functions and classes from the sys1 robots library to control the robot in the simulated world. Once the library is imported, the next step is to set up the environment by loading the world function. This sets up the race course with hurdles that the robot needs to navigate. A robot named Hubo is created using robot, and its behavior is configured with hubo.set_pause 0.5 to introduce a brief pause of 0.5 seconds between movements, making the actions more visible. The robot's trail is set to blue with hubo.set_trace blue to visually track its path. To enable the robot to navigate the course, a helper function turn_right is defined. Since the robot can only turn left, this function simulates a right turn by making the robot turn left 3 times. With the right turn functionality in place, the next critical task is for the robot to jump over the hurdles. The jump_hurdle function is defined to handle this. It begins by turning the robot left, moving it forward 1 step to approach the hurdle, and then turns the robot right twice via turn_right, moving forward after each right turn to cross over the obstacle. Finally, it turns left to realign the robot to face east after clearing the hurdle. Now that the robot's movement and hurdle jumping actions are modularized, the main part of the program begins. First, the robot moves forward 1 step using hubo.move, and then it calls the jump_hurdle function to navigate the first obstacle. This sequence of moving forward and jumping over the hurdle is repeated for times to handle each of the evenly spaced hurdles on Street 1. After overcoming the final hurdle, the robot moves to Avenue 10, Street 1, and picks up the beeper with the command hubo.pick_beeper, completing the task. By breaking down the problem into smaller, modular functions such as turn_right and jump_hurdle, the code becomes more organized and easier to understand. This approach not only simplifies the robot's tasks but also makes the program more flexible, as the same functions can be reused in different parts of the code or future projects. With all of this in place, the robot will navigate the course, overcoming each hurdle and progressing from Avenue 1, Street 1 to Avenue 10, Street 1, ensuring it completes the race while jumping over every obstacle along the way. Alright, that's a wrap for today. I hope you found this video helpful and got some new insights. If you enjoyed it, don't forget to give it a thumbs up and hit that subscribe button so you won't miss out on future content. And hey, I'd love to hear from you in the comments below. Let me know what topics you'd like to see next or any questions you have. Thanks for watching, and I'll see you in the next video.